Hi, welcome to this class. Kinematics. So, up to last class, we discussed types of projectile motion. Types of projectile motion. So, I discussed six types. So, in that, I will discuss what is for you. Oblique projection. Oblique projectile. Oblique projection or oblique projectile, whatever it is. Oblique projection. So, see in this, see what we are doing here. This is x-axis, this is y-axis. So we are projecting a body with velocity u. That body is making angle, velocity vector making angle with x-axis is theta. So this is, you can call oblique projection. So oblique is it should make some angle with the x-axis. Oblique projection. So here this is O is point of projection, U is initial velocity. Just you copy it. So next we are projected with the initial velocity u. So this is a point of projection. U is initial velocity of the projected body. So just I will. So what is happening in oblique projection? So we are projected obliquely. This is x-axis. This will be y-axis. So we are projecting obliquely. So the body is going to some maximum height. Then goes down to the earth. So this is initial velocity. This is point of projection. So already I explained this velocity vector component along x-axis is ux component. So this perpendicular this one uy component. So along this x direction u cos theta. So along this y-axis uy equal to u sin theta. Is it? So what I did now, see, simply I split this vector u component along x component, along y component. So along x-axis ux component, along y-axis uy component, along x-axis u cos theta, along y component u sin theta. is it? Okay. Next, see the ux component will go. So first you draw this one. See, this is along x-axis u cos theta, along y-axis u sin theta. So what I want to calculate, the initial velocity of the body is u. So at this point after time t, in the traveling after time t, the velocity will be v. So this v velocity vector along x-axis vx, along y-axis vy. So vx vy. So this is ux, here vx vy. Vx is equal to ux, u cos theta only. So that is equal to u cos theta will be there. Vy equal to u sin theta. So it is varying up to here at maximum height. What happens? At maximum height, what happens to that? So after time t, the final velocity, see it started with the initial velocity u. After time, the velocity changes to v. At this point, x component is vx, y component vy. So there is no change in along x component. Okay, you just copy it. See, I think you understand. This is initial. After time t, the body is at this place. After time t, the initial velocity started. After time, the velocity is v. So along x-axis, u cos theta, along y-axis, vy. So just I will drop. It's not showing. So here it's not visible that much, so I will draw one more time. See, this is y-axis, this will be x-axis, y-axis. I projected a body with initial velocity u. It is making angle theta. So obliquely projected, it goes to maximum height, then comes down to the earth. So this is x-axis, this will be y-axis, this is origin, point of projection. Here O is point of projection. Okay. So after time t, it goes the body up to here. So initially, this is the velocity. So the obliquely project, the initial velocity component along x-axis will be ux, that is equal to u cos theta. Along y component uy, that is equal to u sin theta. U cos theta, how it is visible to you? The u component along x-axis u cos theta, along y axis u sin theta, that is. So along So if we take horizontal motion along horizontal motion. So ax component along acceleration along x-axis is 0. The acceleration always acts downward. So along x-axis that is 0. Velocity along x-axis u cos theta. So the displacement covered along x-axis, that is equal to ut plus half at square. So along x-axis, displacement along x-axis, sx. Ux is, this is ux, ax. Already I discussed. See, displacement along x-axis, ux t plus of ax t square. So displacement along x-axis, ux is u cos theta into t plus this acceleration along x-axis is 0. So displacement along x-axis is equal to u cos theta into t. See what I am trying to say here. Displacement along horizontal direction, that is equal to u cos theta into t. So this component u cos theta along x-axis, after time t the bodies will be here, but along x-axis the displacement this one, that is sx. See, after time t this the body started with initial velocity u, after time t the body velocity will be v. So the body covered along x direction, along horizontal direction, this is a along horizontal direction. So we did like this, s is equal to ut plus half at square along x direction, along x axis. So sx equal to ux into 2 plus half ax into t square, sx u cos theta into t. This is horizontal displacement covered by the body, horizontal displacement covered by the body when the body projected obliquely. Obliquely means it should make angle theta with horizontal. Okay, we just copy it. From this, for time equal to sx by u cos theta, time equal to sx by u cos theta, sx by u cos theta. The sx means displacement along x direction. So we can say displacement along x direction also, we can say x by u cos theta, whatever it is. It is convenient for you. Which is convenient, you can use that one. See what I did here. We projected a body with obliquely. The initial velocity component along x-axis ux, the initial velocity component along y-axis u sin theta. After time t, the body goes in the plane up to here. So what we want to calculate here, horizontal motion. In horizontal metal or in horizontal motion, how much displacement covered after time t. So for that one, displacement along x direction equal to u cos theta into t. Here along x direction I applied s equal to ut plus half at square. Already we have the formula along x axis, so that's why I used subscript sx ux ax. Sx is displacement along x direction, ux velocity along x direction, acceleration along x direction. Acceleration along x direction, that will be 0. Ux is nothing but u cos theta after time, that is t. Sx is u cos theta into t. So this you copy it. So finally you can write like this, u cos theta into t. Just put t into this one. Next, I am rubbing now. See, we discussed horizontal motion. We discussed horizontal motion. Ux equal to u cos theta. So I am writing just horizontal motion. So ux equal to u cos theta ax equal to 0, t equal to t, sx equal to, you can do this one. Okay, now vertical motion I want to discuss. Vertical motion. So I'm drawing once again. This is x-axis, this is y-axis. This is initial velocity u making angle theta. You projected obliquely. So in vertical motion, so this is a vertical, this is a horizontal. Or vertical motion, so always along y-axis is vertical motion, along x-axis is horizontal motion. The acceleration of the body always minus downward is always minus g. Acceleration along y-axis minus g, ay equal to minus g. Then this is along x component of velocity along vertical direction uy, that is equal to u sin theta, ux equal to u cos theta. So we have now along vertical direction u sin theta, acceleration along y-axis. So y-axis like this is positive y-axis, but acceleration I always x downward, so opposite, take it is minus z. Next, using these two conditions, final velocity of the body, for example this is point A, after time t, it started here with initial velocity u, it goes to A after time t. So what is the final velocity at point A? At point A, what is final velocity? We have the formula v equal to u plus a, v equal to u plus a. So vertical motion, so along y-axis. So just we use subscript y, y, y. Vy velocity along y direction, initial velocity along y component, y direction, acceleration along y direction. Just substitute here. Uy is nothing but u sin theta plus, see ay equal to minus g. So this will be final velocity along y direction of after time t. After time t. So what is final velocity along y direction after time t? So it started with initial velocity u. See vertical motion uy. Then it started in vertically uy sin theta, it started with uy sin theta. After time t, the velocity is vy. It started with uy. We want to calculate vy. Vy equal to uy plus ayt. Uy nothing but u sin theta, ay equal to minus g into t. U sin theta minus gt. So vy equal to u sin theta minus gt. You just copy it. Okay, then already we calculated Sx, that is equal to u cos theta into t. So I want to calculate Sy, the displacement covered along vertical direction, the displacement covered along vertical direction. Sy equal to, already we have the formula, Sy equal to uy ut plus half ay t square. Is it? This is already you known formula. This is kinematic equation is second formula. So Sy, displacement along y direction, displacement along y direction, uy, initial velocity along y direction, ay, acceleration along y direction. So the velocity along y direction is uy, initial velocity component. So displacement along y direction, that means, see vertically how much displaced. See already we calculated, horizontally we calculated. So vertically how much displaced, like this. This is the displacement on y axis. So just substitute uy uy is nothing but initial velocity u sin theta into t plus half ay equal to minus z, so use minus gt square. This is what is this is displacement along y direction in vertical direction, that is u sin theta into t minus half gt square. See now in vertical motion, in vertical motion uy u sin theta ay equal to minus g, t equal to t, sy equal to y, that is equal to u sin theta into t minus half gt square. So we just copy it first. Is it okay now? We calculated horizontal displacement, we calculated vertical displacement. Is it visible? Okay, then you copy it first. Okay, now I am going to give one more equation. I'm going to give one more equation. Equation of, this is also you just write, equation of trajectory, equation of trajectory of the resultant motion, of the resultant motion, equation of trajectory of the resultant motion. So I discussed up to now. See, in oblique projection, so what happens here? In oblique projection, the body starts with initial velocity u, along x component ux, along y component uy. It is going like this. It is making angle theta. So the body, the obliquely projected body, displacement on x-axis is sx, displacement on y-axis is sy. So both displacements are there. For obliquely projection, we have the both displacement. That means along x-axis is there, along y-axis is there. Along x-axis, that is horizontal displacement u cos theta into t. Along y-axis, vertical displacement u sin theta t minus half gt square. So what I want now, resultant motion, horizontal plus vertical. The resultant motion equation, the trajectory of resultant motion equation will be y equal to x tan theta, y equal to x tan theta minus g by 2u square cos square theta x square. So this is a resultant motion equation. So this will be along x-axis horizontal displacement, this will be along vertical displacement. So what I want, equation of trajectory of the resultant motion. So this is like, this is constant ax minus this will be also constant b x square. So this will be, you compare with this equation, so we can say the total trajectory, obliquely projected body, original part will be like this. So it is like a parabola. It is like a parabola. So this equation is nothing but parabolic equation. Parabolic equation. So when a body projected obliquely it goes like this, it will go up to maximum height, then falls to ground to the earth. So this motion, the path of the motion is like a parabola. So today I want to give this much information. See what we did here. Horizontally, component ux equal to u cos theta, ax equal to 0, t equal to horizontal displacement u cos theta into t. One. Vertically motion uy equal to u sin theta, ay equal to minus g, t equal to xy equal to u sin theta of t minus half gt square. This is vertical displacement. So equation of project of the resultant motion along horizontal and vertical. So the resultant motion will be equation ax plus bx, so that is like the parabolic path. So we can say the path of the obliquely projected body is nothing but parabolic equation. Tomorrow we will see some more concepts about projectile motion. Thank you. If you understand, you message me, it is good. Otherwise, message me back. That's enough today. Okay. Tomorrow I will explain one more time. Okay, bye.